The definitions of arc measures are listed below, and the first one, you have a central angle, and that's an angle whose vertex is the center of the circle. So you just draw a circle, and any angle formed in the center, so this right here, this angle that I just formed, because it touches the center of the circle, it's called a central angle. Using that same circle from above, if you draw it again, and we would label it, this is the center, and we would put an A here, and A, a C, a B, and then somewhere over here we put the letter D. We can label a minor arc and a major arc. The minor arc is an arc that's less than 90 or 180 degrees. It's less than half the circle. And we would label it arc AB. For a major arc, it's part of the circle measuring between 180 and 360 degrees. So this arc right here would be the major arc, and we would label it ADB or arc BDA. If you don't put the middle D in there, then it would count as or you would read it as a minor arc. So it's very important that you have the 3 letters there. A semicircle is an arc with endpoints that are the endpoints of a diameter. So if you would draw a circle here, we'd have the middle here, and you'd have your central angle. Just the semicircle is half the circle. So this right here, this angle measure right here, is a semicircle. If you have a circle, or the measure of a minor arc, we have a circle here. It's okay. And we have, this is your minor arc in red, and we would label it something like 50 degrees. So the measure of the minor arc is the measure of its central angle. So we would say minor arc equals 50, and then because the circle equals 360 degrees, then the rest of the circle would have to be, this right here would have to be 310. So we would label it A, C, B, and we'd put our D here, and we'd say arc ADB equals 310. Example 1, segment AB and FE are diameters of the circle C. Determine whether the given arc is a minor, is a minor arc, major arc, or semicircle. So arc AE is right here, which is less than 180 degrees. So that would be a minor arc. Erase that. And then we have arc FA, which is right here, and that would be less than 180 degrees, so that again would be a minor arc. Arc FDE, so FD to E, is half the circle, so we would call that a semicircle. And then we have arc BDA, so B to D to A, again is half the circle, so that's a semicircle. And then we have arc FDB, which is going to be in red, F, and you follow the direction or the order of the letters. So from F to D to B, so I follow it like that. Well, that is more than 180 degrees, so that would be a major arc. The arc addition postulate just states that the measure of an arc formed by 2 adjacent arcs is the sum of the measures of the 2 arcs. So if I had the measure of arc AB, so right here, measure of that arc, plus the measure of arc BC, so you add that on, that would equal the measure of arc AD. B, C. This whole thing added together. So you're just adding those two arcs to equal, add the two red arcs to equal the blue arc. Okay, in example 2, we have circle O, an MQ and NR diameters. That means they go through the center of the circle. Find the indicated measure. Well, MQ, if I draw that line right there, that measure right there is 180 degrees because it's a line and it's a semicircle, so it equals 180 degrees. And so with that information, I can use that to figure out what, and this is 30 in here. So I don't know this right here. So if I would add 70 plus 30, I would get 100. 100 minus 80, or I'm sorry, 180 minus 100 equals 80. So this right here would have to equal 80 because all three of these together, 70 plus 80 plus 30, equal 180. So if I were to redraw this bigger so we can see this better, I have this right here is 30, this is 70, and together we know that this whole thing is 180, so this must be 80 because then they will equal 180. And this also is true about this right here. That has to equal 180, that black arc. So if we have 70 already here, then 180 minus 70 is 110. And then I can also weave around too to this line, this angle right here, and say, well, if this is 110, then this must be 70. And so now we're ready to answer the questions. What's arc MN? Well, M to N, let's go back and erase this. Oh, I want to erase. Okay, so M to N right here is 70. NQR would be N to the middle over here. So that's a straight line, so that would be 180 degrees. Q to R is, Q's right there, so this arc right here is 70 degrees. And QMR, Q to M, Q to M, so I'm going this way right here around Q to M to R, so that's a big arc. That's a major arc. And that would be 30 plus this 80 here plus 70 plus 110, which equals 290. And now we're going to go to P, N, R, and P is right here. So P to N to R. So again, another way to do it is to say, well, the whole thing is 360. So I'm going to take 360 minus this portion right here, which is not included in the arc. So 360 minus 70 would equal 280. Two more definitions for you today. Congruent circles are circles that have the same radius. So if this is 8, then this is 8 if they're congruent circles. And congruent arcs are arcs that have the same measure, and they are arcs of the same circle or of congruent circles. So if we would draw this, arcs that have the same measure, so this arc right here would have to be 60 or 60 to be congruent arcs. They are on this, they arcs of the same circle or congruent circles. So these two would be congruent circles. An example of arcs on the same circle that would be congruent would look something like this. If I said this was 50, and then over here I said this is 50, those would be congruent arcs. They are also called vertical angles. Okay, for example A, or in this example, they want to know if the arcs are congruent. We need to explain yes or no, or why or why not. So in example A, we have arc BC and CD. They are in the same circle, and they are the same measure, so yes, they are congruent. Same circle, and that's abbreviation for circle, and they are the same measure. Okay, for B, we have arc AB and CD. They are the same measure, but the circles are not congruent. So that would be a no. They are not congruent arcs. And the last one. We have arc FG and HG. If you'll notice that the radius is marked the same for both of them. They both have one tick mark, which means they're the equal measure. So that means they are the same circle. Same circle, or I'm sorry, not the same circle, but congruent circles. Erase that. So they're congruent circles, and they have the same arc measure, because they're both 90 degrees. Okay, now you should be ready to start your homework for today, and your homework for today would be 10.2. Good luck.